So here's a strategy. We'll put the strategy off to the side. The way to draw this the most accurately and the quickest with the skills that we have right now is we already learned about the end behavior. But now we're going to use all of our x-intercepts and y-intercepts and the end behavior to be able to draw it very accurately. So what does that mean? This is the main strategy. If we look at this, first of all, we've learned end behavior already. Do you see that this one is odd? And it's a positive leading coefficient, which means that its end behavior is going to act like a line with a positive slope. We know that it's going to start in the bottom left corner and end in the top right corner. Then for figuring out our intercepts, I always start with the y-intercept because it's the easiest. All you have to do is plug in 0 for x. And that is very easy to do. If I plug in 0 for x, I'm going to get 0 plus 0 plus 0. I get my y-intercept to be 0, 0. For my x-intercepts, we have to factor. And this one is actually this example that we're doing right here. We're going to look at the one that the textbook has done as well, because this one's actually too easy. We don't even have to use synthetic division, long division, factor theorem, or the remainder theorem to figure this out. This one is so easy because there's a common factor of x. So I can write that I can take that common factor of x out, leaving me with x squared plus x minus 6. And we get our 3 x-intercepts. So how does this help us graph? And why does this faster than a table of values? Well, for a couple of reasons. One, our intercepts actually ended up being 4 points. We have 4 points like a table of values, but they're 4 very important points. So when I go to graph this, and I label my intercepts, I'm going to have 1, I'm going to have 1 at 0, 1 at -3, and 1 at 2. Those are my 3 x-intercepts, 2, 0, -3, 0. And because I know the end behavior starts down here and ends up here, and I know I have to go through those x-intercepts, now I just have to draw a smooth curve. I need to go through this one. Well, it's going to have to come back down to hit this one. It's going to have to go back up to get there. You go through all your x and y intercepts, match it up with your end behavior, and we actually have a fairly accurate graph. When you're doing the table of values, sometimes you're guessing a little bit. Okay? By fairly accurate, this would receive full marks. I'm going to overlap it in purple and say this would also receive full marks. I'm really exaggerating. The problem that we have in grade 12 still is by doing this method, you've got your x-intercepts, you've got the right shape, but you don't know how high it's going to go. We could put a table of values. You could plug in -1 and 2 to get an idea. but it's not necessary. The purple graph or the blue graph would get you full marks. This red graph would lose you marks because it's not smooth. If you have sharp, pointy lines, if you're in grade 2 connect the dot mode, and you just do sharp, straight lines through all your points, they're going to take off a mark because polynomial curves are smooth. So that red one, by having sharp points when I draw through them, I would lose a mark. But as long as it's a smooth curve, and if you sort of draw it like the blue one, I kind of felt like, oh, I need to start coming back down. Oh, I need to get back up. You get a sense for, like, if you draw it smooth through those, what feels natural is actually going to be fairly close. So this is our new strategy. We want to use the intercepts and the end behavior to graph. We're going to go back and just look at like what usually happens for x-intercepts. We usually have to use the skills that we developed with factoring in the first part where we need synthetic division. So we're just going to look at example 2 that the textbook has done, and it's actually an x to the 4 graph. And we'll just highlight how we would use this strategy to go through the one that they have. So here's their example 2. It's an x to the 4 graph. So if you started with n behavior, you would see that it's a positive even function. There I have my n behavior. And my y-intercept, very easy to find. I plug in 0, and all of these will be 0, and I've got 0, -6. My x-intercepts is going to be a little bit of a challenge because I have to factor this completely. So we're just going to look at the textbook's done this. They used they used the possible factors. What was the actual word we used? Oh. The factor property. They used the factor property to say, these are the possibilities, and they found one that works, and they did synthetic division. I would probably not write this out. I would just write, it's already f of x. Why extra time to write all those out? So you find one factor with a remainder of 0, you write it. Then in this blue box, now I have an x cubed. So I have to do that process again. Synthetic division again with the x cubed until I get another remainder of 0. Then when I rewrite it, I would write f of x again. We have the first factor that we had from before, but now we have a second factor. And we're left with something here, which is a quadratic, which you can factor using your skills with factoring quadratics. So we factor that last one, and you get that whole x to the 4 thing factored completely, which tells you this one, x equals 1. This one, x equals 2. X equals -3, and x equals 1/2. So we take all of our x-intercepts, 1, 2, 3, 1, 2, 3. So what did we find? We found out that there's an x-intercept at 1, an x-intercept at -3, an x-intercept at 2, and an x-intercept at 1/2. And you're going to have to label so that you make sure that you have a scale on your graph. And we found out our y-intercept was at -6. Do you remember this was an x to the 4 graph? A positive x to the 4 graph. So there's our end behavior. Now we have to go through all of these points. and draw a smooth curve through them. So this is how it looked. I know that my end behavior is up here and up here. So I'm going to start on the left. It's got to go through this point, through all of these points. I need to make a small curve, a smooth curve through them. There we go. Okay. This is a typical mistake, and it comes from grade 2, connect the dots syndrome. You're so used to connecting the dots, okay, that when you come through this point, do you see yourself like, ooh, I want to get to this point. Whoa. Like, to make it, if I want to go through this point, this y-intercept and back up, doesn't it sort of make sense that I have to, that you're somewhere your minimum, it's not always going to be perfect, but it should be about somewhere in the middle between those two x-intercepts. It's not going to be perfectly in the middle, but it should be somewhat in the middle. If I made my minimum over here in the purple, to try to make it smooth, I might not pass the vertical line test anymore. And then I'm going to lose a mark for my shape. Or I'm going to go through and then realize I've got it like super sharp, and I'm going to lose a point for a sharp corner there. So I'm going to erase that purple and sort of say, it's not a bad idea. Like when I'm trying to figure out where should I put my minimum to make it smooth, it's about halfway. Halfway between any of your x-intercepts is about where your minimum is going to be. So in this case, I had to go down a little bit further, and then your curve is nice and smooth. Again, where the local maximums and local minimums are, that's next year for AP Calculus. That's one of the things that calculus lets us find very quickly. So much quicker that they don't even bother teaching you anyway, other than using technology to find the maximums and minimums. So if you wanted to find these maximums and minimums, you could use a graphing calculator or Desmos, but on an exam, that will never be asked of you. Okay, questions to circle 7 and 13.